So we have already talked a lot about sequences of numbers. We've talked about arithmetic and geometric and explicit and recursive and all kinds of stuff. So part of this lesson is review, and then it's going to talk about this notation, summation notation or sigma notation. Have you seen that before in science class maybe? Chemistry, it means you add up a bunch of stuff, right? Okay. Part of the lesson originally said to actually take a series and or sequence of numbers and write it in this summation notation, and we're not going to go there because it's just painful. But we are going to review some things like a sequence is an ordered list of numbers. That sound familiar? These two, okay. Kate's question is, do we have to memorize all this stuff? This, somebody want to shut that? And turn on the lights is fine. Well, we're going to leave the lights off. I'm sorry, but the calculator, I know. You can move to the back if you want, but when we put the calculator up, it's really hard to see if the lights are on. Okay, these are the forms for what? These are explicit forms. The top one is for arithmetic and the bottom one is for geometric, okay? That's on the quiz, okay? The rest you have to know. Like the recursive one, because you just say a sub n minus 1 plus whatever, okay? That. All right, so I hope that clarifies a little bit what you're supposed to know. A finite sequence is a list of numbers that ends. An infinite sequence is when you put the dot, dot, dot. Nothing tricky there. You can write a series really as a function where the domain would be restricted. So you understand that this can be a, if I put in a 1, I get out the first term of my sequence. If I put in a 2, I get out the second term, and so on, okay? The explicit form is when it is in terms of n, like the one I had up there. Or if it said some crazy formula like this. That's crazy enough. But that's an explicit formula for some sequence. It means if I want the 10th term, I just put in a 10. Okay, that one's not arithmetic nor geometric, which I think was a point on there, right? It's right down here. Not all sequences are arithmetic or geometric. You understand that you could be doing something crazy? All right, recursive, remember, was based on the previous term. We did some stuff like this, plus the difference, and you also have to tell me the first term and so on. So recursive means it's based on the previous term, and we're good with this notation meaning previous term. Anybody know what this would mean? The term and the term before that. If you said n has to be 2 or greater, this actually works for the Fibonacci sequence. That's the definition of the Fibonacci sequence. If the first two terms are 1, the next term is the sum of those two, which would be, and what would the next one be? You add the 2 before it. Everybody okay? Okay. You add the 2 before it. All right. The only thing on this slide we haven't talked about yet is this, and they're kind of tricky, but we'll get to them later in the lesson. All right, this question is very odd. Take a second and see if you can figure out what's going on. This is +4. Nope, 16. Yeah, that still doesn't say 16. A little scary there. Okay. Sorry. If you were to find the difference again, do you see that this would be constant? They're adding 3 more every time so they're adding an amount that increases by 3. This is actually the sign that it's a quadratic, okay? If it takes 2 layers of differences, then it's a power of 2. There's a quadratic in there. We're going to do quadratic regressions on the calculator eventually. For today, it just wants us to find the next 4 terms, so we're trying to figure it out. We said you keep adding 3 more to what you added last time. So 27 plus 16, I didn't write these very well. 27 plus 16 would be 43, and then you're going to add 19, which is 52, and then add 22. Did I? Oh, this was 62. Thank you. 84. Oh, we got to do one more, it said. And after 22, we'd add 25. Is that right? Somebody checking me? Did I do those right? Okay. How do we find the 6th term of this sequence? Yeah, as long as it just has a plain old n in it, we're golden. We just put in a 6. So it's 1 over, now the 6 is in the denominator, so it's 1/12 plus 2, an exact answer, 25/12. I would take a decimal, but only, I think it ends eventually, doesn't it, or not? Is it an exact? Oh, yeah, then you should give a fraction, because it should be exact. All right. Is this one as fun? Find the 3rd term. Why is this not as fun? Well, because it looks kind of ugly, but what else? It says a n minus 1, a sub n minus 1, that has a negative, and then divide by 3. This means take the opposite of the previous term and divide by 3. Everybody okay? What that means in words? All right. So what do we start with, though? The first term is 9, right? And then if I take the opposite of 9 and divide by 3, opposite of negative 3 divided by 3. Okay, that's the one they want. But if we did one more, the opposite of that divided by 3. So really you're just multiplying by negative 1/3, yes? Okay. It asks for the 3rd term. There's a way to do this on your calculator, but I want to talk just for a second. This one goes positive, negative, positive, negative, but does it eventually approach a value? It gets closer and closer to what? 0? Everybody okay with that? Because it's getting smaller. The next one would be 1/9, negative 1/27. So it's above 0, below 0, above 0, below 0, but every time it's getting a little closer to 0, right? That's the definition of a convergent sequence. It's converging on a single number. Now, a convergent sequence cannot approach infinity or negative infinity. It's got to approach a real number, okay? Here's a disgusting definition. It says a sub n is a sub n minus 1 plus 2 times n minus 1. Well, I'm with you. I'm not going to go out to the 5th, but can we just find a couple of them? How would you find the first one? Well, it told you the first one is 1. Okay, how do you find the next one? A sub n minus 1 would be it means this, right? A sub n minus 1 means the previous term, which was 1. The term, what term are we trying to find? This is term 1. We're trying to find term 2. So we take term 1, which is 1. We add 2 times what? What term number are we on? 2 minus 1. What do we get? 4. Now we're trying to find term 3. So we take term 2, which was 4, and we add 2 times, what's the term number? Then you would take that term and add 2 times, we're on term 4. Those numbers look vaguely familiar. 1 squared, 2 squared, 3 squared, 4 squared. Okay. So that was a very weird definition of n squared, yes? Okay, it was a very painful definition of n squared. All right. Quick one. Who can tell me the next terms of this? Exact values, please. 1 over 5, 1 over 25, because every time they were dividing by 5, we're multiplying by 1/5. Yes, 625. Okay. 10th term of number 2. For number 2, 10th term. Who's got this? 3 times 10 minus 7. Is it right? 23? Okay. Third term on number 3. Is that as easy? No. What's the first term? 3. Then it says you take 1 over 2 times that term, which was 3, so you get 1/6. Then it says to put that back in, 1 over 2 times 1/6. So what's 2 times 1/6? 1/3. What's 1 divided by 1/3? What do you think the next term is going to be? Because you're just supposed to keep putting it back in, right? Okay. Do you think that term converges? No. All the odd numbered terms are 3. All the even number terms are 1/6, but in the end, does it approach a single value? No, it just keeps jumping back and forth, okay? What about this one over here? The idea here was you're going to keep subtracting 7. Okay? Yeah, it's going to be, if you put in a 20, you're not going to, what are you doing? You're actually, that's 60 minus 7 is, yes? If you were finding term 100, this is 53. Oh yeah, I can subtract, just not well. 300 minus 7, 293 maybe? Is this approaching something? It's getting really big, right? Okay. What about this one? 8th term. How do you find the 8th term? It has a cube. Is that confusing you or what? It's still just an explicit form, so you're putting in 8. Everybody okay? And I would take the decimal equivalent of that just because it's an exact decimal, okay? 4th term over here, what are we going to have to do? Yeah, so the first term is 7, and then it would be 2 times 7 plus 5, which would be 19, and then it would be 2 times 19 plus 5. 4th term, we're finally there. 2 times 43 plus 5. Did someone else get that? Okay. So we had to keep putting it back in. That's the definition of which kind of sequence? Or which kind of formula for a sequence? Recursive. All right, we're going to look at the calculator. Ready? Okay. Yeah, we're looking at worksheet 6 for a second. We're going to look at these questions right up top here. What? We didn't finish worksheet 5. No, we didn't. We're going to go back to it. All right. There's there's kind of an old school way to come up with a sequence of numbers on here. I'm going to show you once, but then I'm really not going to encourage you to use it because it isn't all that sweet. We're going to go second, stat, and arrow to the right once. Anybody see anything that looks like it might be helpful? Second, stat, arrow to the right once. Down to choice number 5. Now, if you have a new operating system, the newer one, it looks like this, okay? If you type right now like 3x plus 2, we're doing the first example on your worksheet. Yours gives you 3x plus 2, right? Or 3 theta plus 2. Anybody still in polars? It's fine, doesn't matter. Go down to the next one and hit the variable. Again, n or x or theta. Go to whatever your x key is. Then go 1 for start and 10 for end. And hit enter, and it just gives you a sequence of numbers, and you can scroll to the right to see them. Not sure that was super helpful, but they're there. Okay? Let me show you what the older system looks like, just so you know. If you have the older calculator, when you put that sequence on the screen, then you have to remember all these weird steps. Oh, just kidding. Why is it not doing that? Okay, now mine suddenly won't work. What you have to do is you get the word sequence on the screen, and then after you do sequence, it brings up a parenthesis. You would type 3x plus 1, and then you have to use the comma key, which is plus 2. Yeah, it was plus 2, sorry. The comma key, which is above the 7. Then you would have to put the variable in again, which was x, comma, 1, comma, 10 would give you the first 10. If you want to know the 9th term, do you still have to like go through the list and find the 9th term? It's not that helpful. I'm going to show you a better way. Go to calculator and turn it into sequence mode. Mode. Go to mode, scroll down, sequence mode. Everybody got it? Sequence mode. Everything else can be on the left, but it really doesn't matter. Okay. Go to your y equals and see what you have. Yeah. That's pretty much my first reaction to was like, what is all this garbage? Okay. You need to look here. This is the super important box. Yeah, the color box. No, this right here. Okay. This tells you what all those things are in that screen. All right. So on the calculator, the first one, N min, stands for your starting term number, not the value, but the term number. So we want to start with term 1. We just leave it 1. That is what it defaults to. Yes? Everybody's defaulted to a 1 there? Okay. The second thing, U sub n, is like A sub n. You want to put in the formula. So we just did an explicit formula. What was 3n plus 2? Is that what the question was a minute ago? Let's type that right here. 3. For n, you have to use your x key. You can't use the alpha thing. Use this. You get this funny little scripted n. Everybody got it? Plus 2. Now, because this is an explicit formula, we don't need anything else here. We can just look at the table. Now, if you look at the table, if you have negative numbers, you have an error. Why is that? We told it to start at term 1, and these are term numbers. And it knows that they're term numbers because we put it in sequence mode, okay, guys? If we put it back in function mode and put 3x plus 2, it would put in anything you wanted, right? Okay, but because we told it to start at term 1, it has 5, 8, 11, 14. Are we good? If I want term 77, this is kind of painful. You'd have to scroll down to term 77. It's not a good use of your time. Can I show you another thing? Do you remember when we did Ask Auto? If you go second window and you go down to Ask, now when you go to Table, it says what term do you want? And you could put in a 77 and it would find term 77. Okay, was this a good use of your time? Not so much. If all you wanted was term 77 and you knew this formula was 3n plus 2, can't you just do 3 times 77 plus 2? Okay? Yes. The painful one that it's good for is recursive, yes? If I had a recursive formula and I wanted the 77th term, okay, then I don't know the 76th term or the 75th term or whatever, so I want to, okay. So let's make up a nasty recursive formula. Let's write 1.6n plus 0.2. Okay, it's not really that bad. It's arithmetic, so we could figure it out. But let's find the 70. No, we were supposed to be writing this as a recursive formula. My bad. Okay, do this. Just kidding. Let's do 1.6 times a sub n minus 1 plus 2. I'm just to make it easy. All right, that's our, and we want the 77th term. What else do we have to know, though, if it's recursive? The first term. Okay, let's start with 12. Okay, we'll start with 12. Here we go. By the way, this is probably not going to give us an exact answer, but that's okay. We're going to go back to the definition of the sequence. The y equals key. Everybody good? Okay. This little notation, u sub n, they don't do subscripts. So we just have to use u sub n minus 1, but you have to use a particular u on the calculator. All right. First of all, there was a 1.6 in front of it. So can you type 1.6? Okay. Go clear, go down to u sub n, type 1.6. Now it's going to be times, and you can put the times or skip it. It'll do it automatically. U, the u is above the 7. Do you see a little lowercase u where you do second 7? Okay, that'll give you that special u. You can't do alpha, whatever, wherever the other u was, because it's a capital U. Okay. Okay, don't use that. Okay. Now, to get the n minus 1, there's no subscripts. You just do parenthesis n minus 1. It knows that you have to use that n. The x key, you can't use the alpha n one, okay? Got to use your x key. Now we're supposed to do plus 2 on our sequence. Okay, so 1.6 times the previous term plus 2. Yes, no. This, the term number is 1. Okay, this is important. N min is still 1, but this says use of n min. In other words, what is the value of the minimum term number? The value of term 1 is 12. Look at my little coding over here. Use of n min means put in the value of the beginning term, okay? You only use that if it's recursive, yet it says leave it blank if it's an explicit form, okay? I know this is complicated, but now I can either go to my table and look, scroll down to term 77, or I have Ask Auto and it just found term 77. Yeah, it's a big number. It's 4.997528 e to the 16. So you get 5e16, but if you scroll over on it, it'll try to be more exact, but it's kind of a ridiculous answer. Okay. If we went back and we got rid of the 1.6 and we just put 6 u sub n plus 2, then the 77th term would be a giant number. We could go 0.6 and it would get smaller, but anyway, you get the idea. Yes. Yeah. All right. The other thing we're going to use the calculator for is we're going to graph. Guys, This one we had when we had 1.6. Okay, let's just go on and do the ones they have. Okay. Fibonacci sequence we already talked about, so I'm going to skip this a little bit. Converging and diverging. To be able to see visually if a sequence is approaching a certain number. Do you remember the other day I talked about you put the term number across the bottom and you put its value? If it's a straight line, what kind of sequence was it? Yeah, arithmetic because it was going up by a certain amount every time. Makes sense? That would be called the slope. Okay, if you had a sequence that was, for example, multiplying by, or doubling, we'll say, okay? Started little, it doubled again, it doubled again. It would be doing this, and that's geometric. All right? But it could also be doing this. It could be geometric, and it started at 20, and then it went to 10, and then it went to 5, and then it went to 2.5, and then it went to 1.25. Which of those is convergent? Okay, this one is going up and approaching infinity, which is not defined as convergent. It has to approach a unique number, not infinity or negative infinity. This one is also going up forever. Okay, I could have one that I'm subtracting 7 forever, not convergent. This one, if you're taking half and half again and half again and half again, is it going to ever become negative if it started out positive? No. It's just going to get smaller and smaller and smaller and smaller and smaller and smaller until it approaches 0. Okay? Now, it is possible that it can approach something other than 0. I have students think it can only approach 0. If I did this, 1/2 x plus 1/2 a sub n minus 1 plus 6, where we started at 10. So the first term would be 10, the next term would be half of 10 is 5 plus 6 is 11. No, you're putting, yes. Half of 11 is 5.5. This is not working. I wanted to do one. I did it earlier. What did I do? Okay, we're just going to keep going. Okay. If we put this sequence in, it would give us this graph, and I'm going to show you one in a second. Okay. That is divergent because the left end and the right end, neither one are approaching a particular value. You're looking at the right end, by the way. This one is you're multiplying by negative 1/2 over and over and over. So it says start at 36. Half of that's negative 18. Then half of that, because you're multiplying by negative 1/2, it would be 9, negative 4.5, positive 2.25, negative 1 point, blah, 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 blah. Do you see that it's getting closer and closer to 0 because we're taking half of the number over and over and over? Okay. This one is one like we did a minute ago where it jumped back and forth. So it's divergent. Remember that we had the one that went 6 1/3, 6 1/3, 6 1/3. That's divergent. All right. Let's try graphing this one. Just because it's fun on the calculator and we haven't used this idea. Go back to y equals. Clear out anything you have in there, including anything but the 1 for the minimum term number. Now, when we type this one, this has an n in it, so it's explicit. We're going to type 64 divided by parenthesis 2n. Need parentheses y. Otherwise, the n will go up to the top and it needs to stay in the bottom with the 2. Okay? Now, if you want to look at the values, I'm going to set my table back to auto and just look at the table real quick. What do you notice when you start going down this list? They're getting littler, right? Okay. If you will just do a zoom 0, just kidding. Did it work on yours? Oh, because actually, I don't think that should matter, but did I type something in here that was bad? Okay. Anyway, zoom 0, yours is working. There we go. I know it's like impossible to see mine, but it looks like this, right? Because it is getting closer and closer to what? 0. So this is convergent. How do we type the next one in? Do you remember? What's the first one up top? A 1. The next one you do u sub n minus 1 plus 4. How are we going to put that in? Second, 7 to get the u. Parenthesis n minus 1, close parenthesis, plus 4. And then we arrow down and put in the value of the first term, which was 9. Okay, so if I actually look at the sequence, I'm looking at the table. It should start with 9 and keep adding 4, yes? Okay, just to make sure that this makes sense to you. Starts with 9, add 4, add 4, add 4, okay? If I do a zoom 0 again, oh, please work. Anybody tell me what you got? Yeah, it's doing this, right? Okay, that is divergent. Because it is not, yeah. Yes, Hawken decided. What is it? Doesn't belong to any one of the 4. What? Yes, it is arithmetic and it's divergent. All arithmetic sequences are divergent. If you keep adding something or subtracting something, does that make sense? It's going to either go incredibly high or incredibly low. It's not ever going to approach a certain number. All right, we have one more. 3 to the negative 1n. Well, I can generate the sequence for you. You put in a 1, you get out a negative 3. If you put in a 2, you get out a positive 3. If you put in a 3, you get out a negative 3. If you put in a 4, you get out a positive 3. What do you think? Divergent, because it's just jumping back and forth. Did you graph it and it gave you 2 sets of lines, 2 sets of dots like this? Everybody okay? Anybody not getting it to work? Okay, so that one is divergent. So what do you think about these? At first, I thought the first one was convergent. What's happening? Minus 2, minus 4, minus 6, minus 8, minus 10, minus 20, no, minus 12. Sorry, just making things up now. It's going to get negative and keep getting more negative, right? So this is divergent. What does it have to be doing to be convergent? One more time. It can't be getting incredibly big or incredibly small. It's got to be approaching a particular number. All right. Oh, this is kind of a mess. Let's do this the old-fashioned way. If I put in a 1, I get negative 1 over 2 times 1 minus 1, which would be negative 1, yes? If I put in a 2, square the top, I get 1 over 2 times 2 minus 1, 1/3. Anybody? If I put in a 3, I get negative 1 on the top. 2 times 3 minus 1 is negative 1/5. If I keep going, guys, it goes positive 1/7, negative 1/9, positive 1/11, negative 1/13. What are you thinking? It goes positive, negative, positive, negative, positive, negative, but it does get closer and closer to 0, right? These numbers are getting incredibly tiny. Should we graph it? That makes some of you feel better? Okay, we need to erase all this. It is explicit, so we type parenthesis, negative 1 parenthesis to the power of n divided by parenthesis 2n minus 1 close parenthesis. If do a zoom 0, and it shows that the first term was negative, the next term was positive, negative, positive, negative, positive, negative, but they kept getting closer and closer to 0, yes? Okay. But did we write the word convergent anywhere? Yep, I didn't write it well, but I wrote it. Okay. Oh, this is review. I kind of want to skip this. Can I just go really super fast? Recursive means you need to tell me the first term is negative 4, and then you tell me every term after that is the previous term. Anybody know what they're doing? Plus 3. The explicit form would be a sub n equals the first term plus, anybody remember how this goes? 3 times n minus 1. Good job. And that general form would be at the bottom of the quiz. And you could simplify it, but I suggest you just leave it, because if you simplify it wrong, we'll count it wrong. What's happening over here? They're multiplying the top by 3. They're multiplying the bottom by 1. So the ratio is just 3. Do you see that? Why did I put R and not D? Because you're multiplying, not adding, right? Okay. So a sub n equals a sub n minus 1 times 3, where the first term was 1/2. Anybody remember how the explicit goes? Do you remember why it's in the power instead? Because this one was adding 3, adding 3, adding 3, adding 3. If you wanted to do that 4 times, you'd say I added 4 3s, right? But this was multiplying by 3, multiplying by 3, multiplying by 3, multiplying by 3. If I wanted to say I did that 4 times, you would write this. Does that help you understand why it's an exponent? All right. I'm going to skip some of this vocabulary because I want to get to the fact that a series means you're adding the terms up. We're going to find what's called a partial sum. So if I had this, ... A partial sum would be if I say find the sum of the first 3 terms only. And you'd write 9, yes? Partial sum. So it says find the 4th partial sum of this sequence. If I put in a 1, I get 1. I put in a 2, I get a 7. I put in a 3, I get this. I put in a 4, I get 19. I add them all up, and the partial sum is 22. That seem okay? I'll kind of show you how to cheat and use the calculator next week. And this talks about when an infinite series has a sum. We'll do that next week. Let's do this notation. Okay, before you go. Everybody knows this is called a sigma. It means add things up, sum them. Okay, we're going to talk about this. This means starting with term number 1. Once in a while, they'll put something crazy down here, like n equals 4. It means you don't want to add the first 3 terms. You only want to start with term 4. The top tells you where to stop. So this would mean find the sum of the first 7 terms of this sequence. Put in a 1, a 2, a 3, a 4, a 5, 6, 7, and add them up. Does that seem okay? Does it seem kind of painful? Okay. We're going to talk about how to cheat on the calculator. But before we even leave, I'm going to tell you the best cheat of all. Okay. I'm going to skip to this question right here. Example 5. If you have the newer calculator, and I'm sorry, the older one doesn't do this, go alpha window. What do you see? Number 2 is the sigma. Now, if you had the older calculator, I don't even know if it'll do this. It might do it. 2 to the n, I'm just trying this off the top of my head, divided by 4, comma, 1, comma, oh, maybe n. Yeah, I'm trying the old one. Hang on. I don't know if this is even going to work. Oh, let's see if it works. Okay. If you have the, I got 7.5 doing it with the old one. The new one looks like this. It's sweet. You just type the numbers in. You say n1, and you use n always. And this guy up here, you want to end at term 4. And then over here, you put the formula, which was 2 to the n divided by 4. Whoops, oops, oops, not up there in the top. Yes. Okay. And we got 7.5. So what happened with the newer one, or the older one, was we had to use the summation symbol. Then we put the formula in, the variable, and terms 1 through 4. Either way, it was 7.5. You can now do, guys, most of page 595. There's probably a little, it's 10.1, okay, 595. There's probably a few things we haven't covered, and we'll finish it next week. But the homework check, guys, the homework check is due Wednesday. So Tuesday, we're going to finish this up and finish learning to use the calculator and go over questions. That's it, because the homework check is due Wednesday. Yeah, this is on the yellow sheet. Yes. Anyone else have a question?